We have been finding the probability or proportion given a z-score or an x value. Now what we're going to do is we're going to find the x value given the proportion or probability. So we're going to work backwards. And in working backwards, we're going to start with the z formula, which looks like this. And we can manipulate this algebraically. If you remember your algebra, we can multiply both sides by the standard deviation. That would give us z times the standard deviation is equal to x minus the mean. And then we can add the mean to both sides. And what that does is it comes out with x is equal to the mean plus z times the standard deviation. This right here is actually the same as the z formula, just manipulated to solve where x is equal to it. Okay, we've just solved it for a different variable. And if you recall from algebra, you can do that, just making sure that you follow proper math procedures. And so this is a formula that would be given to you. And so you don't have to memorize it or anything like that. Now, steps to finding a normal value that has a given proportion. First, you want to sketch a normal curve, just like we have been doing. You want to label the mean. You want to label where the value is that you want to find. And you want to shade in the area. If you are given a value to the right, remember you want to subtract it from 1. The big thing to remember here is you're given the proportion, you're given the area. So you have to look that up in the body of the table. Look that up in the body and find the area that's closest to. And follow that out to give the z-score. So what we're doing on this is we're not starting out here. We're actually going to be looking in here and then following it out. Okay? So again, we're going to be following it out and finding the z-score. So let's look at an example of this. We have a normally distributed population that has a mean of 6.9. Okay? So that means our mean is 6.9 right here. And we have a standard deviation of 2.6, which we will come back to. Find the value that has an 80% of the population below it. In other words, the 80th percentile. So 80%, well, right here, remember, from here to the left is 50%. So like if I drew a line here, to the left is 50%. I want 80% to the left, below. So I'm going to have to draw a line over here and shade. So you have to remember that this is symmetric, and drawing that line down the middle represents 50%, or 0.5. So this is the value that I'm looking for. So this area right here, 80% or a 0.80. So I need to look in the center, in the body of the table, for a 0.80. Well, let's go back. This is on the right side of my mean, so I'm actually looking for a positive z-score. So that means I'm going to scroll down here looking for a positive, and I'm going to erase these markings, a positive 0.8. So here's 0.6s, 0.7s. Remember, I'm not looking for this 0.8. I'm looking for a 0.8 in here somewhere, okay? So I'm looking here. Okay, here's 0.7, here's 0.8, so I'm going to start going over. Right here's where I start getting 0.7 and 0.8. So what you do is you kind of start in this first column, going down and seeing where it starts changing. Then you can go over to the right and see where it actually changes. And remember, we look for the one that it's closest to. This one is 5 points away. This one is 23 points away. So we're going to use this number. We're going to follow it out. This one just happens to be a positive 0.8, 0, 1, 2, 3, 4. 0.84. So the z-score is a positive 0.84. Now that's just my z-score. That's not the actual value. The value would be the x value. And so the x value, I have to use this formula. Mu is equal to x is equal to mu plus z times the standard deviation. So our mean was 6.9 plus the z of a 0.84 times our standard deviation of 2.6. And so we get 6.9 plus a 2.184. So our x value becomes 9.084. This is the actual value you're looking for. And in the next video, we're going to do a couple more of these.